Welcome to the lesson on polynomials. Let us now see why you need to learn about polynomials. Polynomials are widely used in almost all areas of science and engineering. They are also used in business, economics, etc. Let us look at a few types of questions that you can answer using polynomials. Polynomials can help design the shape of telescopes. Let us say you want to send some information to a friend and you don't want someone else to know what information you are sending. Polynomials can be used to encrypt data so that others cannot read it. You may want to save money for retirement on a monthly basis. Let us say you're going to retire 40 years from now. Polynomials can be used to determine how much money you should save every month. In this lesson, we will define a polynomial in one variable. We will also learn some terminology related to polynomials. These will help you understand later lessons when we do more useful operations on polynomials. You would have already studied a little bit about algebraic expressions and variables. You might have forgotten it, so let us review the idea of variables briefly. A variable is a symbol that can take real values. For example, let us say a car is traveling at 60 kilometers per hour. The distance traveled can be expressed as d equals 60t, where the variable d represents distance and the variable t represents time. For different values of time, we can find what the distance is. So there is no single value of time. Time can take many different values, and for any value you give me for time, I can tell you what the distance traveled is using the formula d equals 60t. One thing we need to be careful about is that not all symbols are variables. We sometimes use symbols to represent an unknown constant. For example, let us say we don't know the speed of the car. We may write t equals st, where s is a constant speed. Here, s is not a variable. It has only one value, but we don't know what it is, so we have used the letter s to represent it. If you are given a problem, you need to be able to tell whether a symbol is a variable or a constant. A symbol in an algebraic expression is usually a variable unless the problem explicitly says that it is a constant. We usually use letters from the end of the alphabet such as x, y, z for variables. We often use letters from the beginning of the alphabet such as A, B, C for constants. But these are not real rules. So in the example we saw earlier, we had used distance, which is from the beginning of the alphabet, for a variable. And we had used S, which is at the end of the alphabet, for a constant speed. Okay, so you should read the problem carefully to see if something is a variable or a constant. Typically, something towards the end like x, y, z often represent variables, but you should still read the problem carefully. Let us now look at the main topic of today's lesson, polynomials in one variable. Let us first see what is a polynomial. A polynomial is an algebraic expression in which the variable have whole numbers as their exponents. Okay, so for example, if n is 5, then you may have an x power 5. You may have x power 5 plus x power 4, or you could have 2 times x power 5 plus 3 times x power 4, and so on. The a's over here are all constant. This may look a little complex, but if we see a few examples, we will realize that it is not that difficult. Let us look at an example 4x cubed. The important thing over here is that x has a power, and that power is 3. 3 is a whole number. Okay, so 4x power 3 is a polynomial. Polynomials typically have many such powers of x which are added together. For example, I have 5x squared plus 3x minus pi. Okay. Now you may say pi is not a whole number, but pi does not need to be a whole number. Only the power, that is the exponent that goes over x, that has to be a whole number. Others don't need to be whole numbers. Okay. So let us look at a few examples of what are not polynomials. I have 4 divided by x. So 4 divided by x is the same as saying 4x power negative 1. Negative 1 is not a non-negative integer, right? So it's not a whole number, so we will not look at this as a polynomial. 5x power x. Now, the power of x should be a whole number. The power here is x, right? X is a variable, so it is not a single number. Okay, so x power x is not a polynomial. Okay. Similarly, 5x power 1.5 is not a polynomial because 1.5 is not a whole number. Let us do some examples to see if the following are polynomials in one variable. I'm not asking you only if it is a polynomial, I'm also asking you, is it a polynomial in one variable? So you have to ask the question, is it a polynomial and does it have one variable? If the answer to both are yes, then it is a polynomial in one variable. Otherwise, the answer is no. Let us look at some examples. 3x cubed plus 2x squared plus 1. Is this a polynomial in one variable? Yes, it is. Because x has a power 3, which is a whole number, x has a power 2, which is a whole number. Okay? 1 is like saying 1x power 0, right? So x power 0 is also a whole number. 0 is a whole number, so this is also a polynomial. And there's only one variable, x, coming everywhere, so it is a polynomial in one variable. What about 2x squared plus 3x cubed plus 1? This is also a polynomial in one variable. It is the same as the expression above it, except I have changed the order. I have written the 3x cubed in the middle and 2x squared in the left side. Okay, so we don't need to always write the highest power and the leftmost side. We often do that, but you don't need to. Let us consider square root of 5 times x plus 2. Is this a polynomial in one variable? Yes, it is a polynomial in one variable. There's only one variable x. I have a square root of 5. Square root of 5 is not a whole number, but it does not need to be a whole number. Only the power that goes on x needs to be a whole number. Okay? Other numbers don't need to be whole numbers. So this is a polynomial in one variable. What about x power 0.5 plus 2? This is the same as writing square root of x plus 2. Is this a polynomial in one variable? Well, it has one variable, but it is not a polynomial because 0.5, the power on x, is not a whole number. Is x squared plus 2xy plus y squared a polynomial in one variable? It is a polynomial because all the exponents are whole numbers, but it is not a polynomial in one variable because I have two variables, x and y. Let us now look at some terminology related to polynomials. It is easiest to consider it in the context of an example. Let us look at an example of a polynomial minus x cubed plus 4x squared plus 7x minus 2. Each of these numbers between the plus signs is considered a term, okay, or a negative sign too, because minus 2 is just like plus negative 2. Okay, so minus x cubed is one term, 4x squared is one term, 7x is one term, and negative 2 is one term. Okay, so each of these components in the polynomial between the plus signs are considered a term in the polynomial. There is another terminology called coefficient. Okay, so the coefficient of x squared is 4. And it is a number that multiplies the x squared. The coefficient of x cubed is minus 1 or negative 1 because x cubed is, minus x cubed is just like minus 1 multiplied by x cubed. So the coefficient of x cubed is minus 1. What is the coefficient of x? The coefficient of x is 7 because 7 is the constant that is multiplying x. What is the coefficient of x power 0? Okay, remember that x power 0 is just like a 1. It's just like a number. The constant term, the term without an x explicitly written, is the coefficient of x power 0, it is negative 2. Because remember, this is like a plus negative 2. The polynomial has a lot of terms separated by pluses, and so this is like a plus negative 2. So negative 2 is the coefficient of x power 0. The coefficient of x power 0 is also called the constant term. A monomial is a polynomial with only one term. For example, if I write 4x squared, there's only one term. 2x has only one term. 3 has only one term. Okay? Because a term is something that is separated by plus signs in a polynomial. There are no plus signs in the polynomial here. So there's only one term. So these are called monomials. A binomial is a polynomial with two terms. For example, I have 4x squared plus 2x. There's a plus sign that separates two terms, a 4x squared term and a 2x term. So this is a binomial. A trinomial is a polynomial with three terms. Okay, so I have three terms here, each separated by a plus sign, a 4x squared, a 2x and a 3. Okay, so this is called a trinomial. The highest power of a variable in a polynomial is called the degree of the polynomial. Let us look at some examples. In this example, the degree is 5 because 5 is the largest exponent for x. Okay, like for x power 4 has a smaller exponent because 4 is smaller than 5. In this example, the degree is 8 because y power 8 is bigger than 3 or 2, right? And 2, the number 2 itself is just 2 times x power 0, so that one has exponent 0. So 8 is the biggest power, so the degree of the polynomial is 8. 7 is a polynomial of degree 0 because 7 can actually be written as 7 times x power 0. So the highest power here is 0, x power 0. So its degree is 0. What is the degree of 6x squared plus 3x power 5 minus 2? The degree is 5 because the highest exponent you have is 5. Okay, 2 is smaller. 6x squared is x power 2, and 2 is smaller than 5. Minus 2 is like minus 2 times x power 0. So 0 is smaller than 5, so the degree is 5. A polynomial of degree 1 is called linear. A polynomial of degree 2 is called quadratic. And a polynomial of degree 3 is called cubic. 0 is called a zero polynomial and has an undefined degree. Can you give an example of a cubic binomial? You need to think about how many terms does a binomial have and what is its degree. A binomial has two terms and the degree is 3 because we are asking for a cubic binomial. So its highest exponent is 3. So any example with two terms and a highest exponent of 3 is a valid example. For example, 2x cubed plus 3x, it has two terms, so it is binomial. The highest degree is 3, so it is cubic. So this is an example of a cubic binomial. You can come up with other examples. Let us recollect what we have learned today. We have learned what the definition of a polynomial is. We have learned several terminologies like term, coefficient, monomial, binomial, trinomial, the degree of a polynomial, linear, quadratic, and cubic. Once you know all these terminologies, you'll be ready to do more operations on polynomials.